Here we go. So we got sine and cosine. This is from 0 to 2 pi. Okay. Now I said what we're interested in is the enclosed area. The enclosed area from 0, I should put that in, to 2 pi. Okay. So you can see it's unambiguously this area in here. And if you haven't gotten used to it already, do you get some colors? They're so useful. Circle geometry, tree graphs, that kind of thing. Anytime where you got lots of lines and different kinds of things you want to distinguish between. So that's the area I'm interested in, right? Now it is an area between two curves, okay? So if I want to form the integral that's going to give me this area, right? I would say area is equal to, now the first thing I'm going to need is some boundaries, right? Because I want an area, so it's going to be a definite integral. So how do I find the boundaries? I'm going to solve for the intersection of these two graphs, right? So let's just do that very quickly. Sine x equals cos x. That's where the two graphs intersect, right? Sine x equals cos x, okay? So you can divide both sides, give you tan x is equal to 1, of which you should be able to give me the two values. What are the two values? Okay, so first one, pi over 4. We know that one pretty well, okay? And because tan is periodic, your next answer of course will be 5 pi over 4, because you've got to go forward pi radians. That's the period, okay? So therefore, pi over 4, 5 pi over 4, those are our boundaries. Good. So I'm going to slap that onto my definite integral. Now, seeing as it's a area between two curves, right? Rather than work out two separate areas, two separate integrals, I can whack them into one. How will I do it? I want to think about the one that's on top, right? Which in this case is sine. Okay? And then I can subtract the area underneath. Now, be careful. There's an area underneath the curve here, right? Sorry, underneath the axis. What difference does that make to the integral that we form? Now, don't forget, I'm doing an area between two curves, right? So, had I just calculated, for instance, this area, these two boundaries, and just did sine, or just did cos, right? Then part of those would be negative. But because I'm doing this subtraction, right? I mean, remember we gave this illustration. If I took the whole thing and I just moved it up, right? Instead of taking sine x and cos x, you know, if we did some kind of vertical shift that took the axis out of the question, right? Sine x plus 5 and cos x plus 5. If I form this integral, right? Sine x plus 5, cos x plus 5, right? You'd get exactly the same integral, right? So in fact, even though part of it is under the axis, it doesn't matter. Okay, it doesn't matter precisely because it's area between two curves. All right. Great. So that's that with respect to x. All right. You can walk me through this. What should I write? Square bracket. Negative cos x. Good. This is negative cos x here, so that should go to negative sine x, like so. Okay. And evaluate at the boundaries. Okay. Slap a minus sign out the front there. Okay, now, can we do this? How well can we do it in our heads, do you think? The 5 pi and 4 one, minus, okay, cos of 5 pi on 4 plus sine of 5 pi on 4. Who reckons they could do their exact value? Think about it. So that's going to be, sorry, this is negative 1 on root 2, because your base angle is pi on 4, right? So it's 1 on root 2, but thinking about the quadrant here, what about sine 5 pi on 4? I'm not getting much consensus. Think about it. Negative? Plus? Negative? Plus? Which quadrant are we in? Think about it. You're in the third quadrant, right? So that's why they're both negative. Okay, great. That's that. Now, I haven't done this other side over here. That's just pi on 4 plus sine pi on 4. Okay, so therefore, These are easy too, right? Yeah, you could go there, couldn't you, right? But I'll do both. Okay, there you go, and we can simplify from there. Okay, just for the sake of it. Let's see, negative. This will be negative 2 on root 2, which is just negative root 2. And this will be the same. So you're going to get 2 root 2. Now that's the integral, okay? And the integral doesn't have units on it. I would conclude, therefore, the area is. And I'd slap the units on there. Sweat. Okay, fantastic.